Hello, 6th graders. This is Mr. Humphreys. We are in section 7.5, which happens to be the last section of the chapter. So let's start off with our key idea about using the Pythagorean theorem. So our key idea talks about the converse of the Pythagorean theorem. It states that if the equation a squared plus b squared equals c squared is true for the side lengths of a triangle, then the triangle is a right triangle. So let's put this into action. Example 1. Now the directions state, tell me if that's a right triangle. Notice I don't have a right angle here, so you have to prove to me if that is a right triangle. We do that by doing the opposite of the Pythagorean theorem. We do the converse, which states that if you actually do the Pythagorean theorem, then it's a right triangle. Rather than doing the Pythagorean theorem, rather than seeing that it's a right triangle and using the Pythagorean theorem, we reverse it. So let's plug it in. 9 squared plus 40 squared equals 41 squared. That gives me 81 plus 1600 equals 1681. That gives me 1681, which does equal 1681. You have just proven that that is true. So the answer will be yes, this is a right triangle. Example B, I want you to do yourself. Use the Pythagorean theorem and see if that's a right triangle. Pause the video. By using the Pythagorean theorem and plugging in all three sides, we simplify it and we see that we get the equation 468, which does not equal 576. So, no, it is not a right triangle. Your next key idea takes what you discovered yesterday, which is called the distance formula. The distance formula says that the distance d between any 2 points given by the ordered pairs x sub 1, x sub 2, and y sub 1, y sub 2 is given by the formula d equals the square root of subtracting the x's squared added to the difference of the y's squared. Now let's actually put a graph with this so you understand what we're doing. Distance formula and Pythagorean theorem can be used to solve the same type of problems. So if I had, let me erase that here. If I had an ordered pair, x1, y1, and another ordered pair, x2, y2. To find the distance, I can use the distance formula. But in addition, you could also make a right triangle out of this, and you could actually use Pythagorean theorem as well. Example number 2. Find the distance between the points 1, 5 and -4, -2. Now I'm going to show every single step. You do not need to show me every single step, but you need to show me most of them. So I'm going to first write down the distance formula. Once again, if you do not want to write down the distance formula on your homework, you can go right into solving the problem. But for your notes, I want you to write this down. So what we're going to do is we have 2 points. Now, either one of these points can be your x sub 2 and x sub 1, and either one of these points can be your y's as well. But here's the premise of what you're going to do. You're going to subtract your y values. You're going to subtract your x values. You're going to square both of those numbers, and you're going to add them together. The final step is taking the square root. So let's start plugging everything in. X sub 2. That's going to be -4 minus x sub 1, which is 1. Then I square it. Plus y sub 2, which is -2, minus y sub 1, which is 5. I square it. The distance then gives you -4 minus 1, which is -5. Do not put that. That is not right. -5 squared would be -25. I'm telling you, this is a mistake that I see all the time, and I will count it wrong if you're not precise. Because you need to have the negative 5 in parentheses. Having the parentheses and not having the parentheses mean two separate things. Negative 2 minus 5 gives you negative 7 squared. Negative 5 squared is 25 plus 49. That gives you the square root of 25 plus 49, which is the square root of 74. And the square root of 74, if you take the square root of that, gives you, I'm pulling up my calculator here, the square root of 74 gives you approximately 8 6/10. If you had a unit of measurement, you would need to write down inches or centimeters, whatever we're talking about. Example number 3. Now, this one is in your book on page 321, if you want to follow along. It says that you design a football play in which a player runs down the field, makes a 90-degree turn, and runs to the corner of the end zone. Your friend runs the play as shown. Did your friend make a 90-degree turn? Each unit of the grid represents 10 feet. This is definitely a multi-step problem. This problem, you have to determine if it's a right triangle. Is this angle right here a right triangle? The problem is we don't know any of the sides. We don't know a single one of them. So we have to start by finding the distance of each side. So this is going to be a long problem. So here we go. D, distance 1, you can see it right here, D1. We're going to subtract our x values. So we're going to take 60 minus 30 squared plus subtract your y values, 50 minus 20 squared. Now I'm going to skip some steps here. 60 minus 30 is 30. Squared would be 900. Plus 50 minus 20 is 30. 30 squared is 900. The square root of 1800 gives you approximately 42.4. Now wait a minute. You're like, we're going to round. We can't round because we have to take our value of what we get, and plug it in. So if we round, it's not going to be accurate when we plug it into the Pythagorean Theorem. So we can't use that. We're going to leave it as just the square root of 1800. D, sub 2. Subtract your x values. So that would be 80 minus 30 squared. Subtract your y values. That would be negative 30 minus 20 squared. 80 minus 30, that's 50. 50 to the second power is 2500. Negative 30 minus 20 is negative 50 squared is 2500. That gives me the square root of 5,000. D sub 3. Subtract your x values. Doesn't matter what you start with. I'm going to start with 80 minus 60 squared. Plus, subtract your y values. Negative 30 minus 50 squared. That gives me 20 squared, which is 400, plus negative 80 squared, which is 6,400, which gives me a value of 6,800 feet. Those are our three sides. So now we have to plug it into the Pythagorean Theorem. So a squared, 1,800, squared, plus the square root of 5,000, squared, equals c squared, which is 6,800, squared. Now you should remember a squared and a squared root cancel each other out. So you're just going to be left with 1,800 plus 5,000 equals 6,800. We add 5,000 together. We get 6,800 equals 6,800. This is true. So did your friend make a 90-degree turn? The answer is yes. Your friend did make a 90-degree turn.